Hello everyone, this is Mr. Math Guy, coming to you from the very popular Mr. Math Guy YouTube channel. So what I want you guys to do today is just do the do now, do A and B, make sure you show all your work, state, plan, do, conclude, and pause it and play it once you're done and I'll show you the answer. For the state part, make sure you state the parameter. I probably should have put the true or the population proportion. I guess this is of all U.S. adults, so that's fine. The confidence level is 99%. Our first 99% confidence interval. Oh joy. The plan. This is the thing I see a lot of students forget. It's a one proportion z interval. If you say one sample z interval, that's fine as long as you say for a proportion, because we will be doing one sample z intervals, not that much of them for means. Check your conditions. 1, randomly selected. We can use the point estimate. 2, 10% condition. 3, make sure it's approximately normal with the large counts condition. Here is the do step and the conclude. So it asks us, does the interval from part A provide convincing evidence that a majority of all U.S. adults think the organic produce is better for health? So majority would be over what percent? 50%? If it's 50.0001, that's a majority. So is all of the percentages, plausible percentages above 50%? And they are. So yes, we do have convincing evidence for that because all the plausible values, 0.5167 to 0.5833, are all greater than 0.5. Let's go to the next page. This is going to make that do step so much easier. Is we can actually do the confidence interval in the calculator. So instead of doing this red do step right here, we don't need to do any of that really and just plug it in the calculator, so it makes it really nice. So the way we would do that is you want to press stat and then you go over to tests and then be careful. There is one prop z test. We're not doing tests yet. That is that's going to be next unit. We're doing intervals, confidence intervals. So you want to scroll down. Do not click z interval. Z interval is for when we're doing means, if we know the population standard deviation, which we don't know, so we're not going to be using z interval that much at all. We want one proportion z interval, which should be, you keep scrolling, should be at A. So that's one proportion z interval. When you click it, the X is how many people responded to our actual survey for a success. So 55% for this one. It doesn't give us how many, so you actually need to do 0.55 times the sample size to get the number for X, because X is the number of successes, if we think about it as binomial. N is the sample size, confidence interval 0.99. Make sure you don't put 99. One thing to note is, for the X value, it has to be a whole number. There are some questions where if you do 0.55 times 1480, I know it's not the case for this one, you might get 814.2. So if you do get that, you can't put the 0.2 there because that's like saying 814.2 people responded that they do a certain thing. That doesn't happen. So you just want to make sure you round it. So in this case, if it was 814.2, for the X, you would just want to put 814. I've seen a question like that trip up a lot of people, and just make sure you round that number if you need to. So when you put in the calculator, it does a do step for you. Look at that. Look how easy that is. So what you could do from there is it even gives you p hat. Well, we already put the sample size in. So that's all you need to do for the do step. You just need to do stating the confidence interval like that, and you're done. So much nicer. Makes it a lot easier, I think. So that's it for the calculator. So I want to do a couple that kind of practice just using the calculator. So let's go to the next page. So remember the general formula for a confidence interval. It's always the point estimate plus or minus the margin of error. And the margin of error is always the critical value times the standard deviation of the statistic. In particular, the formula for the confidence interval for a population proportion is you take the statistic, which is p hat, you multiply it, or you add or subtract the critical z-score plus, or not plus, but times the standard error of the standard deviation. So what is the margin of error for the confidence interval? Well, it's just the part that you're plus or minusing. If we want to, limit or make the margin of error like maybe 0.02, or limit like kind of how wide our confidence interval is, what is the only thing we can change in our margin of error? And I guess we could technically change the z-score, but say we want a 95% confidence interval, we can't change that. We don't want to make it like a 99.99999% confidence interval. We don't need it to be that specific. We don't want it to be like a 60% confidence interval. So what we usually do is 99, 95, or 90. We stick to it. So we don't want us to change the z-score. So what else could we change? We have no real say over p hat. That's just due to our sampling. So the only thing we can change is the sample size. So that's where we're really going to focus. If we want to have a small margin of error, or like some said margin of error, say we want the margin of error to be 0.05, so like 5%, then we have to change our sample size to kind of get us to that 0.05. So if you are planning a study, you will need to choose a sample size. You want to choose a sample size that allows us to estimate a population proportion within a given margin of error. To calculate the sample size, we must substitute values for the margin of error. So we get the z-score from whatever we want our confidence level to be, and p hat. And then we solve for n. So that would give us a one variable equation. When we set up the equation, but a lot of times we don't know what p hat would be because we didn't actually go out and do the sampling. So there's two ways of estimating a p hat. The best way, if it's available, we can use a guess for p hat by using some pilot or like study that was done beforehand that was similar, and we can use that p hat value. If we don't know that, we have to use p hat equals 0.5. We use that as a guess because the margin of error is going to be largest when p hat is 0.5. So we want to be as conservative as possible if we don't know or don't have any idea what p hat can be. And I know there would be a question, wait, why is a margin of error largest when it's 0.5? So just think about some numbers. I'm going to do some numbers right up here. So think about some numbers. If I do like 0.5 times 0.5, that would be 0.25. But let's see how it changes as our p hat gets smaller. So let's do like 0.4 times 0.6. You can see that's getting a little bit smaller. So our margin of error is going to be a little bit smaller. And then if we keep going, you're going to see as we keep going, the margin of error is going to be getting smaller and smaller. So if we have no idea what the p hat could be, we want to be as conservative as possible. So we want to use p hat as 0.5. So sample size for a desired margin of error when estimating the population proportion. To determine the sample size, then, that will yield a confidence interval for a population proportion with our stated maximum margin of error, so like 0.02. You want to solve this inequality. So the margin of error, and you want it to be less than or equal. You want it to be less than or equal whatever the percentage is. And we're going to do a sample question next. So take a second and read this question. So we're creating a 95% confidence level interval. So we know that z-score is going to be 1.96. And we're trying to, we want the estimate to be within 3 percentage points. So that means we have to do plus or minus 0.03 or less would be nice, within 3. So our margin of error we want to try and obtain is 0.03 or less. So we're going to have our margin of error formula. Remember, it's z times p hat 1 minus p hat all over n, radicaled. And that is our margin of error. So we want our margin of error to be within 3 percentage points. So we're going to, within, we want to use an inequality. So that means our margin of error is going to have to be less than or equal to 0.03. So our z-score is 1.96. We're trying to figure out how large a sample needs to be within 3 percentage points. Our p-hat value, does it give us anything in here? It does not. So if we don't have any previous experience or any previous survey or previous study to go by, we have to use a p-hat value of 0.5. And why 0.5? Because we have to be as conservative as possible. If we don't have any previous information, we have no idea what the p-hat can be. So multiply that by 1 minus p-hat, which is still 0.5, over radical n. And this just becomes an algebra question, really. So I want you guys to finish off 1, do number 2, pause the video, play it once you're done, and we'll go over them. Main thing for this one is don't round anything to the very, very end. You might have gotten a different answer than me if you did. So when I first divided both sides by 1.96, I didn't round it yet. I just kept it as it was. Then I squared both sides here. Multiplied by n on both sides, because n was in the denominator. And then you can divide by 0.03 over 1.96 squared. And then all this is all on one side. I have no idea what that is. Just put it in the calculator, and you'll get 167.1 repeating. So n has to be greater than that. So the next number greater than that would be 1,068 customers. And number 2, very similar question. But in this case, it actually gives us a previous survey, so we don't use 0.5. So if you circled 0.5, that would be incorrect, because we want to use a previous survey if we got it, because that's related to what we are trying to do, so it gives us a little bit better of information. So we use that, and it's asking us for a 98% confidence interval. Don't see 98% that often, but that z-score would be 2.33. So that would be choice D. So that's it. The other packet is just practice with all confidence intervals for proportions.